Hello, everybody. Thank you for joining us today. Hopefully no one's too offended by the title. It's my favorite title of all time for one of our webinars. But I know I've been out on jobs and felt very much that way about things before. So we actually had one of our wonderful customers come to us with a project, and that, as you guys will see, pretty much describes the problem they had. So yeah, if you're going to do it, go big or go home, right? So yeah, we'll get kicked off here pretty quickly. First, I want to go through some housekeeping stuff. In general, we're going to be recording the presentation. So if you have to drop off, if you come in late, not that you'll hear this, you will be able to kind of watch the thing later if you want to send it around in your company, show anybody else. You're all going to be muted during the presentation. We will do some Q&A at the end, but we'll be doing that through the questions section of the GoToWebinar. So if you go in your little panel, you'll see there's a place you can ask questions. Please do. We would love to have those, particularly during our panel discussion as well. And then if there's anything we don't get to there, we'll try and answer any leftover questions during Q&A. And then the recording link will be sent out about a week after, gives us time to do any little editing and stuff like that. So with that, let me introduce our crew today. So we've got a number of people on from ClearEdge, but most importantly, we have our wonderful customer, Brent Godfrey. Brent, why don't you introduce yourself?
Thanks very much, Kitty. Yeah, so my name's Brent. I'm a surveyor based way down here in South Africa, and yeah, I look after scanning and the BIM side of things here at our company. My career leading up to this has always been in and around sort of the construction and engineering surveying, with always keeping a focus on sort of new technology and stuff in the world. Worked on various types of projects from mining to civils to buildings, and now sort of using 3D scanning in all of the above type of projects. Yeah, happy to be here.
Brent was also one of our early beta testers for Veritys. That's actually where I first got to know him. So yeah, thank you for joining us today, Brent. We also have James Norris with us today. Say hello, James.
Hey there. Hi, everybody. I'm James. I had just recently joined ClearEdge 3D. I used to be the Director of Virtual Design and Construction for the Beck Group, which is a design build for commercial space. And I came on board just because of the amazing technology and a strong passion and belief in reality capture and kind of creating field verification workflows to solve a lot of the pains that we have in construction and design. So,
and he is literally paid to say that. Thank you, James. Zoltan, why don't you introduce yourself as well?
Hello, everybody. I'm Zoltan Ferenczi. I joined ClearEdge about a year ago on the industry strategy team, and I came from kind of a long history of working with CAD software, particularly architectural software, an Autodesk reseller, and also doing laser scanning and helping architects to utilize laser scans in their workflows.
Excellent, thank you. And Jason, the Viking, please introduce yourself.
Hey everybody, my name's Jason Moran. I'm the product manager for Edgewise Verity Rhythm. Unlike these other guys here, I'm not, a construction guy. I'm a software guy, so I've spent a little bit of time in, AutoCAD, a whole lot of time in Edgewise, but basically I work with industry strategy, our sales team, our service team, and our customers to make sure the changes we're making to the products are basically, tailor-made for what you guys are doing. So I'm happy to be here.
Awesome. And just in terms of the agenda, all four of these wonderful gentlemen are going to be doing kind of a panel discussion for the last half of the webinar. But the main event, of course, is Brent's presentation on this wonderful project that we're going to hear all about. So, yeah, Brent, take it away.
Right, yeah, thanks very much. Hopefully you'll find this quite interesting and relative to what you guys do in projects that you've experienced. The project I'm going to run through with you today to explain sort of the scenario that led up to this project coming about. There's a large residential development. It was comprised of multiple blocks, all reinforced concrete frame buildings, all multiple stories. And unfortunately, the original contractor that was awarded the work wasn't performing very well, both financially and also with regards to the quality of the work that they were busy producing, which ultimately led to this company folding and going bust halfway through the construction. So this left the client with a whole bunch of half-complete structures, and the structural engineer, who wasn't really satisfied with what had been produced, wasn't very confident in the structural integrity of what had been left behind. They'd been given some as-builts from the original contractor, but this had just been possibly done by a tape measure and was a very biased as-built. Just from visual inspection, you could see that things shouldn't be trusted and that there were major problems on site, and yet the documentation was saying that everything was fine. So our deliverable was essentially to do a proper as-built and show how these existing structures, how they conform to the project specifications. Now, we are to now show the dimensional defects with as much of a visual impact, a visual representation as possible to the whole project team, because everybody was obviously interested in how this building looked, and the project team included the client, the architect, the engineer, the new contractors, and some of the people probably aren't used to reading construction drawings, so we wanted to make it as visual as possible. And then obviously the final deliverable also was specified that it had to be something that could be printed to paper and physically filed for record keeping purposes. So therefore we also needed to be in a readable 2D format by people who don't necessarily have access or experience with working with electronic 3D data and working with 3D models. Now, some of the project challenges that we came across was, first and foremost, was to convince the project stakeholders that actually scanning and doing a 3D analysis was in fact the correct and really the only way forward to understand what these as-built conditions were and give it to them in the detail that they required to understand the structural integrity of the building. There were other alternatives put forward, such as they were originally just going to scan the buildings, do a 3D laser scan, and just take a slice through the building and do a comparative 2D analysis as to how the columns compared to the design positions. But that, to me, that misses, you're missing the point of doing a full 3D scan and just doing a 2D comparison. Why, you need to know twist, tilt, rotation, all that type of information. And if you do a 3D scan, do a 3D analysis. That was our point for this whole project. The other challenge was that the quality of the build was really poor, and you'll see it further on and what challenges this brought about. It wasn't just a case of seeing things a few millimeters out of spec. The other thing was that all the existing documentation, the whole project had been designed in 2D. There were all 2D AutoCAD drawings. The engineers and the architects all were working on 2D CAD. So before we could start, we had to take their 2D drawings and we had to create the 3D models to do the analysis.
And this is one of those interesting things because to do this full 3D analysis and get all those benefits, we do run into projects quite regularly where people want to take advantage of laser scanning and do all this, but they're working from 2D drawings and they see that as this really big barrier to doing that. But I think you had made a point sharing this project with us before that, if you've got good CAD drawings, if you've got good backgrounds, taking that and turning it into a 3D model just is surprisingly fast.
Yeah, definitely. I agree. And it's, my answer to that is, what's the alternative? If you had to, it was still a lot faster to take the existing drawings and create the 3D models up front and do a 3D analysis and present it in a 3D way than to try and do sections and elevations and to try and represent the as-built in a 2D manner. It would have taken us a whole lot longer than it took us to just build the 3D models in the first place. So it was a requirement, and it saved us time at the end as well. So the other challenges was, the buildings were half built, and there was absolutely no record of the site control, the grid lines that were used to set these buildings out. So, we had to make sure that now we had to take a design and we had to fit it to what was physically left on site. So in doing this, we had to take into considerations all the elements of the building. For example, we couldn't just measure the 4 outer columns of the structure and then fit the design to that, because this would make sort of the internal shear walls, the larger items, look like they were far out of tolerance, and then the repair costs would have escalated. So we had to try and best fit the design to the existing structure on site to minimize the rework that was required for the building. We couldn't just take the original design position and use that because the deviations were too far out to start off with.
And this is another thing that I really thought was interesting, because we always, one of the things we tell our customers with Verity is, hey, you want to be on control, you want to do this so that you get accurate results as opposed to kind of relative but precise results. And the thing that was so funny to me about this one is this is actually a case where it's like the results were so bad if they were accurate that there was an intentional decision on the project team to choose a precise result because it ultimately didn't matter where exactly the building was built on this larger site. It was just a matter of, how do you best fit what's there to what was supposed to be there so you can move forward with the project. So that was kind of a really interesting tweak on normal projects.
Yeah, it was. Also the cost saving in doing so was immense, and you'll see it from the results later on. How much that reduced the amount of rework just by adding that step into the process, doing the analysis. So our workflow once on site, we used Trimble SX10 laser scanners. Integrated with Trimble R2 GNSS receivers, and that's what we use to establish our control. And then we use Trimble TX8 scanners to do the internal and external scans of all the buildings. Now, to process the scans, we registered everything in Trimble RealWorks. We then had to export everything to structured E57 files, then into Recap, and then brought it into Navisworks. It was a bit of just a lengthy workflow. I just think that, Trimble Railworks wasn't able to export a structured RCP file. It can export RCP, but it's obviously Verity needs the structured format. But it's just one of those things that you program to happen overnight, so it doesn't really impact your workflow, your time frame. And then, so before we could even start our report on the deviations, we had to calculate this final new design position. Now, to overcome this challenge of this new design position, we ran a full analysis of the whole block in Verity based on the theoretical position of where the structure should have been in the first place. And out of that, Verity, in its summary report, we took something what it gives us, which is called a bias error value. Now, this is exactly what we needed. This is basically, it's the average shift of all the items in the analysis, but it's weighted based on the surface area of the items. So the smaller elements, the small downstand beams, the small columns, they had less of a weighting on this value than the larger items like the shear walls, and we excluded the things like the floor slabs and things that wouldn't affect the 2D positioning, XY positioning of elements. And then we shifted the design model by this bias error value, and then we reported on the deviations based on this. As you can see from the pictures here on the right hand side, the deviations were they're quite large. The construction, the specifications, the tolerance for this building is that dark green value. It's supposed to be 0 to 15 millimeters, class 3 classification for specification. So, I mean, from that you can only see there's very few items that fall within that band. So if we had to just do a simple showing it in out of tolerance, it wouldn't show much. We wouldn't be able to understand much about what was happening in the building. So we actually had to go up and create different categories, different bands based on the magnitude of the specification that it had to be in. So we had to go, what your tolerance is supposed to be, then double your tolerance, 3 times your tolerance, 4 times your tolerance, 5 times your tolerance, and then after that I just called it blunder. I believe the Verity, you guys at Verity would have called it the FUBAR band. But
guilty.
Yeah, we had we had to try and come up with a way to actually visualize the magnitude of these defects, and yeah, I'll show you how we did that. So in addition to just measuring the horizontal displacement of the items of these buildings, we also measured things like the vertical alignment of columns and walls, the rotation of these columns, the verticality of facades, to try and understand whether sort of the outer skins of the brickwork would make it past the slab edges, or whether the shelf angles that were being installed for the brickwork to be installed on, were they thick enough to carry the brickwork if you had to now try and make the outer skin a vertical wall. We measured the slab thicknesses, the levelnesses of the slab. And that was great for the engineers to, if they could see that the levelness of a slab was out, and now they needed to make a decision on what the remedial work would be, they could overlay the two, and you could see, if they needed to scabble off areas, is the slab thick enough? Would there be enough? Do they need to go and have scanning done for cover for rebar? Or if they were going to add additional topping, is the thickness of the slab, is it going to be able to take the loading of the extra topping? And then what we did to create, as you saw on the previous slide, all those categories, those groups, we found it really fantastic to be able to, inside Verity, use the results table inside Verity. It sorts it all nicely into the categories of the results. You can choose which category you're wanting to analyze, and you can sort it by that category. So you can sort, it's like an Excel spreadsheet. You sort it by that column from smallest to largest. And then you can create your band, select your band of items that fall within that area of interest, and then export that selection set into Navisworks. So now you have that selection that you've highlighted in your spreadsheet, if you like, now selected inside Navisworks to create your own selection sets in Navisworks, and you can colorize them as you like. And this obviously gives you infinite amount of options to create visualizations and various reports.
Another good trick is if you push the properties in, you can also use the search sets in Navisworks. So you can build searches for tolerance ranges. That way, if you make adjustments or change the analysis, you don't even have to redo the selection sets. So, pro tip.
Yeah, you'll have to teach me that one. And you know, another thing we found useful was, you know, with Verity, we were able to take the design model and then automatically, by one click of a button, update that entire design model into the as-built position. Then, if you re-import your design model just under a different name into Navisworks, you now have your as-built versus your design side by side, and you can see your model highlighted to see which elements have major defects. And you can also see how all the surrounding, where it sits in the building, what sort of effect it's going to have on surrounding elements. So not only can you just click on it and see what in the properties, how far out what the magnitude of that offset is, you can also see, you know, which direction it is without having to look and try and understand which way is positive, which way is negative. You can just physically see it, and you can make decisions because you can now tell, is that column that's out, is it in a passage? Is my passage now becoming narrower? Are my staircases becoming too narrow? Is it an escape route? Does it need to be? You know, you can make these type of decisions almost immediately just by having one quick look at what you've got in your model. So as for what we had, which came out of this, is now we had an adjusted design model with new grid line positions, new floor levels. So now the project could move forward. They had a base where to work from to move the project forward. Now you'll see that the tolerance to design was improved by 40% by shifting the design. We could now improve to see how much the building was within specification, so a whole lot less rework. We had a model with everything highlighted in their magnitudes of tolerance, as I showed before, so in their bands of their magnitudes of 15 millimeters. And the engineers were now able to create a design with what they had on site to see what could stay and what had to be repaired. So then now the project had a way forward. This is just an example, well, just showing you what I've been speaking about before, about the improvement we made by shifting the design onto that bias error that was given out by Verity. On the left-hand side, you're looking at a graph showing out of all the elements that were analyzed in Verity, what their conformance to specification was. There was only 3% that fell within specification. If you consider your work to be double your tolerance to be acceptable, which in most places you wouldn't, you still only sit with 10% of your building falling within that specification. But after we shifted everything to that biased best fit error, you now look at the chart table on the right hand side, and you can see how we've now gone from a green component of 10% up to 42%. So it's a massive improvement and a massive amount of rework that less rework that was required. I think in most cases they were able to design out around most of the errors, and only the bands that were sort of sitting in the red and the brown were areas that needed now serious attention. But now that reduced from 36% down to 6%. So there was a great saving on that side.
I have to give a shout out to our development team, because when we were going through designing the reports, they were trying to figure out, what kind of aggregate results we could give that would be interesting. And, I'd come up with a bunch, and then one of the people on our dev team was like, well, why don't we do a weighted analysis of the results? And I was like, what do you mean a weighted analysis of the results? He's like, well, we've got surface area. We could weight on surface area, so things with large surface area have a bigger impact. I was like, I don't think anybody's going to know what to do with that, but yeah, why not? It sounds like a cool feature. And so like, I can't tell you how excited I am that somebody has like found that and actually used it on a job for something meaningful. So I know our developers are going to be all excited about that too. So yeah, it's fun to see.
Very, very cool feature, I must say. Yeah, definitely came into handy. I don't know how else we would have had to do that, how you would choose where you choose, how else would you choose your base point? As I said earlier, you don't, it's out of the ordinary. You're not just comparing against design, you're now trying to, try and fit something in a most cost-effective way, and this was ideal to it. So whoever put that idea forward, hat off to you. It worked. So some of the other things that we did, it wasn't only what we looked at earlier was just sort of the XY positions analysis we did. We obviously looked at things like verticality of everything. We looked at horizontal rotation of our elements. And you can see from these results, I mean, they were, the guys got things okay. They got them pretty vertical. They weren't too twisted. So there was a problem with the setting out. There was clearly an issue with the stretch tape measure. I don't know what it was, but the setting out was the issue. Maybe not so much the guys that were actually doing the erecting. So just a couple of things that I have learned from this project, and probably some tips for anybody else that's wanting to do something similar and to take things, some lessons learned. It's just, make sure that, when you do this project, that when you finish, go through your steps of your registration, your data conversion, then doing your analysis, and then doing all your results. Make sure that your point cloud is fully registered and cleaned before you start your analysis, and so on, just to make sure that you don't want to have to go back at the end and say, well, actually we've missed a bit, and I need to add a scan in, but I've already analyzed stuff, or there's a scan that's missing or not registered right, and you've already done your analysis. To try and go back all those steps, or just to try and fit an element that has been analyzed already into an existing building is quite a task. So just do things step by step. The next thing, sorry, let me just.
Oh, it's just.
Wasn't expecting the landline to go.
Yeah. The joys of being in an office, somebody else's landline. That's great.
Yeah. Apology.
It happens, man. I'm sorry. Continue.
Yeah. So the other, use your results table to sort and create various selection sets. So I know Veritys got the great, you've got the standard colorization tools where it tells you what's in, what's out, what's missing, and it's great to understand to have those. But I mean, your options are limitless. So being able to sort and create your own selection sets and report on that is yeah, it's fantastic. And then using the as-built design position simultaneously in your Navisworks model for understanding of, not so much understanding of the defects, but what impact it has on the surrounding items, what impact it has on the rest of the project. As I said, you know, is that deviation making a passage narrower? Is it making a staircase narrower? What are the other impacts that it has on your structure? And then, you know, something else, it's fantastic that we have these tools, and we here at Cape Servo, we follow the technology, and we like to stay up to date with all these great, you know, all these new innovations. But sometimes we're delivering this type of information to people whose roles are different, and they might not have as much access to the software that we have access to. So we need to try simplify your output as much as possible. In these two pictures on the right-hand side, the top one is one of the clients, they used Civil 3D. So we were able to give it to them in their format from Navisworks. And the bottom picture is actually of a 3D PDF. I mean, that has all the information inside there. There's the as-built model, the design model. You can see the as-built and the design side by side. And everybody's got access to a PDF and people, you can rotate it and visualize it, take cross sections, you know, you name it. And also, you know, file size, sharing the information. We sat with possibly one building was about 10 gigs of data on our PC, but in that PDF with all that information inside there, that was only 97 kilobytes. So we could, that was just through a free plugin called Bluebeam inside Navisworks. So that was, you know, it's great to be able to share your information as well with as many stakeholders as possible in different formats. And yeah, I think that sort of concludes my presentation on my project.
Awesome. Well, thank you very much for taking the time to share that, Brent. That's it's fun because this is, you know, literally the thing we it's literally the thing we designed Verity to do, is to help out on these kind of projects and help figure out what's actually gotten installed. So it's always fun to see that. So now we're going to go into our basically panel discussion. We've got our wonderful ISR team, industry strategy team, acronyms, bad habit. We've got our product manager, Mr. Jason Moran, and of course Brent is sticking around. And I think you know, our goal in this was to kind of share similar experiences on other projects that we've helped out with, that we've been engaged with, both at ClearEdge and in our careers. Because I think something that we always see when we go out to job sites is, or go out to projects is, you know, I think people have almost a false sense of security about how their building is going, and you know, how their project's getting built. And almost without fail, when we run out and help somebody run Verity on a project, they discover that maybe things aren't quite as well built as they were hoping, and it helps usually find unexpected errors. And so, yeah, just wanted to kind of get all the panelists on. We can turn our webcams on so people can see us. Also, we're taking questions during this, so please hop into the GoToWebinar questions panel, and you can start pushing in questions through that if there's anything you want the whole group to kind of discuss or answer or talk about, including questions about Brent's project. So, and with that, gosh, I think I'm gonna kick off the questions while we're waiting for a couple more to come in here. So now that James and Zoltan, you've kind of heard this about this project in a little more detail, is there anything that sticks out to you guys about it that speaks to you? Let's do, yeah, James first.
Sure. I think that the big thing I've noticed is going back to your point, Kelly, where we have these assumptions that our jobs are going well. A lot of times, like the erosion in our fees and the profits we're trying to make come from the things we don't see. And it kind of becomes more and more evident the more you find out. I mean, a good example, I've been on projects in the past where we might be joint venturing with another contractor, and maybe they're in charge of building the base. Maybe it's the parking deck, and then we're building the high rise on top of it. And you just have two separate firms that you're relying on each other, and you can lead with this assumption that the structure is right, and a lot of times it's not. So traditionally, you would have to spend time scanning or surveying all these different points to validate the structure, and it's a time waste, and there's just things you may not find or see. And really what was striking for me, Brent, was just the ability to quickly analyze all of these different structures, whatever phase they were really in the construction process, to highlight the tolerance issues. Because even with scanning, like you still have to visually go back in and do that, if and it's just cumbersome, and things will be missed, which ends up being like a change order on the job that the owner, whoever is funding it, has to pay for, that's unforeseen, and it just leads to delays on projects. So things like this are a huge deal. I mean, I was looking at, like, if it's 36% initially, if like you have control and you've got the building where you think it's supposed to be and it's off, you have this 36% deviation, and when you weighted it, you went down to 6%. And if you think about a job that size, let's just make up a number. So let's say the scope of structural engineering or for structure is $10 million. And based on your analysis, it was 3.6 million, 36% is 3.6 million of that. And now we're down to 6%. Now it may not be totally 3.6, but we're down to 600 grand. You've definitely saved the client at least over $1 million. I don't know where it lives, but it's a huge deal. And it was like effectively automated based on, the guidance you gave it. I think for me, that's pretty rocking. So.
Yeah, on the thing that I always see on job sites, right, is because there's a perception that it takes too long to check everything. They don't check everything, and what you end up checking is a small, percentage of stuff that the superintendent or the GC is worried about, and then you just kind of hope and pray all the other stuff is correct, and
right.
it's just it's never that way. Yeah, Zoltan, what did you take away?
So one of the things Brent was talking about is when you understand what parts of the design are not conforming to the tolerance, you can also get a sense of how that affects other aspects of the design. Like you were saying, if it's going to affect how wide hallways or stairwells are. And this is kind of important because a lot of times these downstream problems actually end up costing more than the initial problem, because doing changes and rework in construction projects tend to get more difficult and more expensive as the project progresses, because oftentimes you have to remove more materials or redo more things. And so by catching these errors early in the design process, the cost savings is actually not realized up until the snowball effect would have caused a much larger problem later in the project. For example, if you had some rigid duct work, if the duct hanger is in the wrong place and you didn't notice it and the duct goes in wrong, if you catch it at that point, it's a pretty easy rework to redo a section of duct. But if later this duct connects to, let's say, some sort of laboratory fume hood, and that gets placed wherever the duct is, and then the laboratory casework is placed wherever the fume hood is, if you don't notice that until they realize that it doesn't match the utilities in the floor, doing the rework at that point is much more costly. So finding these errors is as much about finding them sooner as they are about finding all of them. and also being able to analyze the effect of these errors to see if it's even going to be a problem. Because just because something is out of tolerance doesn't necessarily mean it has a downstream effect on anything that necessarily has to be redone. Or you can just change other criteria in the design to make it work. For example, we were doing a scanning on a project that had these custom-made metal wall panels on the exterior cladding of the building. And it was noticed pretty late that the structural steel that held all of the substructure that held the panels was a bit out of plumb, so that at the top of the panel, at the top of the wall, the structure may have come out of the panel face. So this would have required redoing the panels to make the panels deeper. But by analyzing exactly how much it was out, it was determined that there was enough play in the substrate that they could just adjust the shimming of the panels and it would all work anyway. And so being able to see that something that's not conforming to tolerance is not actually a problem means that you don't have to do rework if it's not necessary. And doing this type of analysis gives you all of that.
Yeah, you made a really good point. I think something, a tool like this for long lead items, so cut stone and metal panels are a big thing. And if you think about anybody who's ever built a building, or these things have to mount to a substrate. You've got this structural steel that has to go up, and you mount this thing against it, and which is your substrate, and then your metal panels or your stone mounts to that. Well, this stuff is cut like 3 months prior, or it's in queue.
Absolutely.
And if it's not right, you're hosed.
There was absolutely. This reminds me of another project where there was a kind of an ornate stairwell that had these custom-made glass fiber reinforced gypsum board pieces that made like kind of a gypsum pocket, and these were made overseas, and they had like an 8-week lead time. If the substructure that held the panels in place was not correct, it would have actually caused the opening of the building to be pushed back because of the lead time to remake those panels. So some things you just can't get it wrong because of the lead times that are required to rework some certain items.
Yeah, and those are great points. And I do want to, ask Brent a little bit here. I know this is not your first project to do this kind of analysis on, obviously. Have you got any other good war stories you want to share with the audience?
Yeah, I mean, there's also one of the byproducts of doing this type of analysis is that also a lot more people actually look at the results. So traditionally, I don't know how it works in the rest of the world, but here an as-built would consist of a 2D plan with a couple of arrows showing with a 2 pointing up, saying 2 that way, 10 that way. And for people to actually go through and read that, they're going to look at it and go, what does that arrow mean? Does that mean, is that the direction that's it's supposed to be the design, or is that the as-built direction? And it takes a long time to sift through that sort of information. And now, because it's such an easy, quick way to look at the results that you get by looking at a 3D model and just looking at the colors, I mean, anybody can understand that. We found that information got shared a lot better, and it got shared in sort of weekly management meetings. So if it was done on a regular basis, it was almost used as a tool for sort of QA to try and monitor sort of the progress on site, which was never, as-builts weren't used for that function beforehand. And it picked up quite a few other things on the way, because now you have different stakeholders looking at the data. And it's not always the Veritys stuff. I mean, we had a case where there was a large excavation, and there were piles that were being held back by temporary work supports, and we could see from the analysis it wasn't even the fact that it hadn't come up in the Verity results, but because there were lots more people now looking at the data, somebody else just looked at it and said, oh, look, but surely that temporary support is now going to be in the way when we get up to first floor. And it was a big operation to have to move these. I mean, it was 3 stories down in the ground to have to redesign and remove the temporary supports and redo the temporary works design to make sure that it wasn't going to clash with buildings. So I think that the sharing of the information as well also helps in, people picking up problems and errors before they become expensive problems. So.
Oh, thank you. I like you just used our tagline, and I think it was intentional. That was beautiful.
Yeah, I think that's great. One of the things I've always found really exciting and interesting about Verity, Zoltan and James just gave some really great specific examples of things gone wrong on the project, but Verity does so much automatically and gives you high-level reports and all kinds of things that it does more than just point out maybe mistakes in construction. It also kind of enlightens you and brings about a change in the way you think about the way projects are going and the way projects are done, and people can consume this information in a new way. You go out on the job site with a tape measure, sure, you can figure out that column's in the wrong place, but Verity, you can push a button, get a report, and like you said, share that with stakeholders, share that with people who couldn't consume that information before. And it's, I've seen time and time again, it's enlightening. People come to us with, oh, we said we'd, build everything within this spec, and there's just no way. It's unrealistic. It's impossible. You type that tolerance into Verity, and everything starts flashing red because, of course, it's not there with 5 millimeters, 10 millimeters. It's but that's equal in value to just knowing that there's a mistake, is being able to look at it from a bird's eye view and think about things in a new way because you have all of this statistical information about your project, right?
Yeah. All right. Well, I want to take just a minute to answer a couple questions that we've got coming in from people. So one of the questions that we got is actually related to time frame and resolution of scan data, basically just the amount of time it takes to kind of go through this type of analysis. Apparently they're using an RTC at high resolution. And then trying to pull this in, and I'm guessing this person may actually be using Verity, but at a high level, I want to just kind of, as a heads up, mention that Verity does not need high resolution data to give you very accurate results. Because of the way things are statistically fit and averaged, a couple thousand points on a beam is going to give you a really accurate fit of that beam. You don't need 100,000 or 600,000 or 5 million. You're going to get marginal to no difference in the results afterwards. And so, one of the things that I always tell people is don't scan at high res if the goal is to go out and run Verity, because it just basically, every doubling of the resolution has a 4x doubling in the size of the data, which has a 4x increase in the amount of time it will take to process and analyze it. So, it's, I think one of the arts of scanning out in the field is knowing what you're going to be using it for and then scanning accordingly. And of course, if you've got multiple purposes, you may need that high res data and you need to decimate it. But yeah, Brent, you want to talk a little bit about kind of time frame and resolution settings and stuff that you used on this project?
Yeah, so we did exactly that. So we, for one of those blocks, so I don't quite know the square meterage of it. There's 4 stories. We would typically get through one of those in 2 days. We used 2 TX8 scanners, but we scanned on the lowest resolution. So they scan at sort of 1 million points a second, which is pretty standard nowadays. And we did it on 1 minute scans. So that's the shortest possible that we could do. And as you say, it was because we did that extra process of having to go through to structured E57 and then into recap and then into to Navisworks. it sped up that processing time a lot. And also what was nice is we didn't have to, with a lot of this, with Verity only extracting the data around your design elements, we didn't have to worry about cleaning too much, spend too much time cleaning the data. Obviously, when extreme cases, we did. We also didn't have to scan in color. It's not a requirement, so that speeds up your fill time as well. But yeah, so a 2-day block, and then we could probably have the Verity results, the registration and the analyzing was probably another day or so in the office. I think we found we spent most of our time actually in Navisworks creating these 2D documents that were required by the clients, actually doing the final reports and converting the models to make it interpretable to people who weren't used to aren't accustomed to using 3D data models is where we spend most of our time. But yeah, I mean, those buildings were turned around quite quickly.
Yeah, that's if you can optimize for the use case, you can usually do things pretty darn fast. Obviously, a lot of these things on larger jobs get processed overnight. And I'll use this as kind of a opportunity to pitch our industry strategy team, basically, and people we've got on this call, in the sense that, Zoltan's got a lot of experience working with Faro scanners and Scene, and James and I have a lot of experience working with Recap and Cyclone, and so if you've got a particular part of your workflow that is taking a lot of time, or you feel maybe needs some optimization for you to be getting the best value out of it, part of why we built up this team within ClearEdge was to really provide some help and assistance just back to our customers and potential customers about, how can you get this done quicker or smarter or whatever, based off the experience that we've got and the contacts we have in the industry. So I know Joseph's been asking some questions about this, and what we'll do is I asked Joseph just to follow up with me afterwards, because I think there's some things we can do to help streamline the deresing of that high-res RTC data, hopefully. So we have another question about the project here. You mentioned that the registration of the point cloud is important, but did you use the same control points on the job site which were used to lay out the structure, Brent?
So we've got a cadastral sort of system here in South Africa. So we used what we call our town survey marks, which were adjacent to the site. So theoretically, those should have been used in the first. There was a design position already, which theoretically should have come off those control beacons in the first place. So yes, we did use that to set out the original position of the building, but that obviously wasn't done very well in the first place by the first contractor, because by doing the adjustment, when we run the first analysis, there was, if you look at my color coding, everything fell into the blunder FUBAR category. So, we had to sort that out. But yeah, we did use that same theoretical control that they should have used. But each structure was different. So you could tell that some buildings were shifted different to other buildings on the same project site. So there was a bit of an error somewhere in the setting out originally, but we had used theoretically the same control.
Yeah, and I'd add to that. I come from a surveying background originally, and quite a lot of jobs, like especially jobs where it's more than just one building, they may have set their own control, and they'll end up, somebody will shoot in a corner of a building and another side of it, and it might be mildly rotated, and they just and because of speed, they go vertical and they can't stop. And to Brent's point, like theoretically, we've got this control that everything should be tied into, but you'd be surprised the amount of jobs that are not laid out right. And then you just have to deal with you have to deal with things relative to that building. I think that's probably a big beauty of Verity, because then you're waiting relative to like that thing specifically, rather than holding true to control, because it doesn't matter anymore. And you're just trying to save the client money at that point. So.
Yeah. And one of our audience members, Dennis, pointed out that 3 millimeter, 5 millimeter tolerances, they're just impossible and unreasonable on any normal construction site. And it is a challenge, I think, in the industry that we have these tolerances that are just fundamentally not achievable. We're certainly not going to be the ones to solve that problem, but I do think that's a great conversation to have, certainly at industry associations, wherever it is that you are practicing work, and try and surface those conversations, because a 5 millimeter global tolerance on concrete is just never going to happen. The formwork deflects 5 millimeters when you fill it up. So, it's just, part of the balance is having reasonable tolerances, but part of the balance is also having reasonable ways to check reasonable tolerances. And I think that's where our industry has really struggled, the last 30, 40 years, 50 years, well, forever, not having reasonable ways to check these much more complex and much larger buildings. All right, we got one last question here about as-builting. So Brent, you mentioned that you had as-built the model, and to clarify, that's in Navisworks. This person is asking, is there a way to get that back into Revit? And so I'll just shortcut the answer here. The short answer is no, and we're working on it. So we've been working on trying to get Verity working inside of Revit, and not sure when we're going to be releasing that, but the short version is since people don't actually want perfectly as-built geometry in Revit, because they want to do things like dimension to it and cut sections through it and all this other stuff, it's actually a much more complex process than getting an as-built in Navisworks. But there's some really neat workflows in 2019 and 2020 where you can load in a coordination model into Revit as a background. So the same trick Brent used to get the as-built and as-designed Navis model in Navis, you can actually do that in Revit and load in the as-built Navis model into Revit, so you can see your as-built Verity geometry in context with your Revit model inside of Revit, which at least from my experience, makes it a lot easier to go in and selectively as-built the Revit model without having a massive point cloud loaded in. So maybe not the perfect answer, Talal, but it's hopefully an answer that might help you out if you want to give it a try. So,
but if it's something that was that is critical, we managed to try. It's a long workaround, but that was one of our clients in that same project wanted that same thing, and we took it out via FBX to Civil 3D or to AutoCAD, and then from AutoCAD back into Revit. So you can have that position there, but you haven't got the data. So yeah, that data component is missing, but the as-built object is there.
Yeah, and trust me, we want to get this working inside of Revit and other things like Revit sooner than later. So I think as interest grows on that and we get more people using the product and asking for it, obviously that will happen sooner. So, and with that, we are at time. There's a couple other little questions that we didn't get to, and we'll follow up with after the webinar. And otherwise, thank you so much to our wonderful panel. And Brent, thank you so much for staying late and taking the time all the way from South Africa. And
Thanks.
We'll shut it down. Thank you, everybody, for listening in and watching.
Bye.